Hariom students, all of you are obeying the instructions given by our government for road safety. You maintain 2 meter distance away in public place. Always to remember it. Then what is today saying? Never compare yourself with others. You are unique. How proud on yourself. നമ്മൾ ഒരിക്കലും നമ്മളെ മറ്റുള്ളവരുമായിട്ട് താരതമ്യം ചെയ്യാൻ പാടില്ല. ഓരോ മനുഷ്യരും വ്യത്യസ്തരാണ് അല്ലേ? ഓരോരുത്തർക്കും അവരവരുടേതായ വ്യക്തിത്വമുണ്ട്. അപ്പോൾ അതുകൊണ്ട് നമ്മൾക്ക് മറ്റൊരാളുമായിട്ട് നമ്മളെ കമ്പയർ ചെയ്യാൻ ശ്രമിക്കരുത്. യു ആർ യൂണീക്ക്. ഹൗ പ്രൗഡ് ഓൺ യുവേഴ്സ്. നമുക്ക് നമ്മളെക്കുറിച്ച് തന്നെ ഒരു അഭിമാനം ഉണ്ടാകണം അല്ലേ? ബി പ്രൗഡ് ഓൺ യുവേഴ്സ് സെൽഫ്. അപ്പം നമ്മൾക്കുണ്ടാകുന്ന കഴിവ്, നമുക്ക് മറ്റുള്ളവരുടെ കഴിവുകൾ കണ്ടിട്ട് നമ്മൾ തീരെ കഴിവില്ലാത്തവരാണെന്ന് വിചാരിക്കുന്നത്. നമ്മൾക്ക് ദൈവം പല കഴിവുകളും തന്നിട്ടുണ്ട്. ആ കഴിവുകളെ നമ്മൾ വികസിപ്പിച്ചെടുക്കാനായിട്ട് ശ്രമിക്കണം. അപ്പം അതുകൊണ്ട് നമ്മൾക്കുള്ള കഴിവുകളുടെ അഭിമാനം കൊണ്ട് അതിനെ വളർത്തിയെടുക്കാനായിട്ടുള്ള ശ്രമം നടത്തും. അപ്പം നമ്മളുടെ ജീവിതത്തിൽ വിജയം ഉണ്ടാകുന്നതായിരിക്കും. ഓക്കെ. Then today we can do some problems based on circles. One question: a point M is 26 cm away from the center of a circle and the length of tangent drawn from M to the circle is 24 cm. Find the radius of the circle. Here a point M. Look at the figure. A point M is 26 cm away from the center of the circle. So this distance is OM is equal to 26 cm. And the length of tangent drawn from M to the circle. Here this MN. This is a tangent to the circle. This is a point of contact. And MN is the tangent to the circle. So it is equal to 24 cm. Find the radius of the circle. So here what is given? OM is equal to 26 cm. And MN is equal to 24 cm. Then look at this. What type of triangle is this? What is ON and MN? Is there any property for ON and MN? Kailas? Here ON and MN. We already studied a theorem that the tangent is perpendicular to the radius to the point of contact. Here what is the point of contact? This is the tangent and this is the radius. So the point of contact is N. So we studied that this radius is perpendicular to the tangent through the point of contact. That is ON is perpendicular to MN. This figure here ON is perpendicular to MN. What is the reason? Because tangent is perpendicular to tangent is perpendicular to the radius through the point of contact. Radius through the point of contact. Tangent is perpendicular to the radius through the point of contact. So ON is perpendicular to MN. Then this is a right angle triangle. So in right triangle OMN, we are asked to find the radius of the circle. Then to find the radius, OM is equal to 26 cm. MN is equal to 24 cm. Then find the what is ON? In right angle triangle OMN, we can use Pythagoras Theorem. Then ON square is equal to OM square minus MN square. OM square minus MN square. What is OM? OM square, that is equal to 26 square minus 24 square. 26 square minus 24 square. OM square is equal to OM square minus MN square. So it is equal to 26 square minus 24 square. Now then what is 26 square? 26 square is equal to 676. 24 square is equal to 676 minus 24 square is equal to 576. So ON square is equal to OM square minus MN square. So 26 square minus 24 square, that is 676 minus 576. So it is equal to 100. Then what is ON? Therefore ON is equal to square root of 100. ON is equal to square root of 100. And then what is the square root of 100? Anand? It is equal to 10 centimeter. 10 centimeter. So the point M is 26 cm away from the center of a circle and the length of tangent drawn from M to the circle is 24 centimeter. That is OM is equal to 26 centimeter and MN is equal to 24 centimeter. Then here ON is perpendicular to MN because tangent is perpendicular to the radius through the point of contact. Then if ON is perpendicular to MN, or triangle OMN is a right triangle, therefore ON square is equal to OM square minus MN square by Pythagoras Theorem. That is 26 square minus 24 square is equal to 100. Then what is ON? Therefore ON is equal to square root of 100. That is equal to 10 centimeter. Therefore the radius is equal to 10 centimeter. Therefore radius is equal to 10 centimeter. Okay. Next we can study a theorem. The lengths of tangents from an external point to a circle are equal. If we draw two tangents from an external point to a circle, then they are equal. Here P is an external point to a circle, and if we draw two tangents from this external point to the circle from to these two distinct points PA and PB, then we are asked to prove that this PA is equal to PB. That is the lengths of tangents from an external point to a circle are equal. Then what is given in our question? Given a circle with the center O, P and PB are the tangents drawn from external point P to the circle. Here given a circle with the center O, and PA and PB are two tangents drawn from the external point P to the circle. Then what we have to prove? We have to prove that AP is equal to BP. That is this distance AP and BP, they are equal. That is the lengths of tangents from an external point to a circle are equal. Okay. Then what we construct here to prove this, we join OA, OB and OP. Then you draw in dotted lines. This is construction. If you draw any line to prove this, then we draw dotted lines. Okay, use dotted lines to draw this construction. Join OA, OB and OP. Then what is it? We already studied theorem that a tangent from a point to the circle is perpendicular to the radius through the point of contact. Then here the OA is perpendicular to AP and OB is perpendicular to BP. That is tangents. If we draw a tangent the tangent is perpendicular to the radius through the point of contact. You remember that theorem. Okay. Then here this is the radius and this is the tangent. So OA is perpendicular to AP, and similarly this OB is the radius and BP is another tangent. Then this tangent is perpendicular to the radius through the point of contact. That is OB is perpendicular to AP. So what is the reason? We know that a tangent drawn from a point to the circle is perpendicular to the radius at the point of contact. Therefore OA is perpendicular to AP and OB is perpendicular to BP. Then look at the triangles. Then there are two triangles in that figure. Triangle OAP and triangle OBP. Look at the triangles OAP and the triangle OBP. Here angle A is equal to angle B. Why? Angle A is equal to angle B because it is 90 degree. Because if we draw a tangent, we know that tangent is perpendicular to the radius through the point of contact. Then angle A is equal to angle B because each 90 degree. Then OA is equal to OB. Why? Look at the figure. OA and OB are the radii of the circle. So OA is equal to OB. Then OP is a common side to both these triangles. In triangle OAP and triangle OBP, OP is a common side. Therefore, we can say that OP is equal to OP because it is a common side. Then triangle OAP is congruent to triangle OBP. Why? Because one right angle, the hypotenuse and the other sides. The OP is the common. OP is the hypotenuse of both the triangles. The common. This is a right angle, therefore OP is the hypotenuse of this triangle, and angle B is a right triangle, therefore OP is a hypotenuse to the triangle OBP. Therefore, triangle OAP is congruent to triangle OBP by which congruence rule? RHS congruence rule. Triangle OAP is congruent to triangle OBP by RHS congruence rule. Why these triangles are congruent? Give recognition. Right. What is RHS congruence rule? In a right triangle, if one angle is a right angle and the hypotenuse and one side of a right triangle are respectively equal to the hypotenuse and one side of the other triangle, then by RHS congruence rule, these triangles are congruent. Right angle, hypotenuse and side. RHS. So, if in two triangles, if two right triangles, the hypotenuse and one side of a right triangle are equal to the respectively equal to the hypotenuse and one side of the other triangle, then by RHS congruence rule, these two triangles are congruent. Therefore, triangle OAP is congruent triangle OBP. Then what about AP and BP? Now, AP is equal to BP. Why AP is equal to BP? Triangle OAP is congruent triangle OBP. Then AP is equal to BP. Abhishek, why AP and BP are equal? By CPCT. By CPCT. First, corresponding part of congruent triangles are congruent. Here, triangle OAP is congruent triangle OBP. Therefore, AP is equal to BP. That is by CPCT. So, the lengths of tangents from an external point to a circle are equal. This is an important theorem. Study the proof also. It's very important. So, the length of tangent from an external point to a circle are equal. That is, given a circle with the center O and PA and PB are tangents drawn from external point P to the circle. Here PA and PB are the tangents drawn from this external point P to the circle. Then to prove AP is equal to BP. Then construction, we join OA, OB and OP. Then a tangent drawn from a point to the circle is perpendicular to the radius at the point of contact. Therefore, OA is these two lines are perpendicular. Therefore, this angle is a right angle. OA is perpendicular to AP and OB is perpendicular to BP. Therefore, in triangle OAP and OBP, two triangles are there. Triangle OAP and triangle OBP. Then here OA is equal to OB by the radius of the circle. Angle A is equal to angle B because it is 90 degree. Then OP is equal to OP. OP is the common side. Therefore, triangle OAP is congruent triangle OBP by RHS congruence rule. Then if the triangles are congruent, we know that the corresponding parts are equal. Therefore, AP is equal to BP. Then look at the figure. What is AP and BP? AP and BP are the two tangents drawn from the external point to a circle. Therefore, we prove that the tangents drawn from an external point to a circle are equal. That is, AP is equal to BP. This is very important. There you study it well. Okay. Next question. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. Here given two concentric circles C1 and C2. What do you mean by concentric circles? Sarman? Two circles with a common center. So given two concentric circles C1 and C2 with center O. PQ is a chord for larger circle. Here the larger circle is C2. Then this PQ is a chord of the larger circle. And with center O, PQ is a chord for larger circle C2 which touches the smaller circle at R. This chord touches the smaller circle C1 at R. Then to prove that PR is equal to QR. Here PQ is a tangent for the smaller circle. Then here PQ is a tangent for the smaller circle. Then we can say that OR is perpendicular to PQ. Why? PQ is a tangent to the smaller circle. So Vaishnav, why OR is perpendicular to PQ? Because tangent is perpendicular to the radius to the point of contact. Therefore, PQ is a tangent to the circle and OR is the radius. So, the tangent is perpendicular to the radius. That is, OR is perpendicular to PQ. A tangent is perpendicular to the radius at the point of contact. Then PQ is a chord of a circle C2 and OR is perpendicular to PQ. PQ is a chord of the circle C2. PQ is a chord of a circle C2 and OR is perpendicular to PQ. PQ is a chord of the circle C2 and OR is perpendicular to PQ. Then OR is the bisector of PQ. If OR is perpendicular to PQ, we know that the perpendicular from the center to a chord bisects the chord. Therefore, if PQ is a chord and OR is the radius, then the OR is perpendicular to PQ. Then we can say that OR is this perpendicular from the center to a chord bisects the chord. Therefore, what we can say? OR is the bisector of PQ. This OR is the bisector of PQ. Then OR is the bisector of PQ means this OR bisects this chord. Then what we can say? Then PR is equal to RQ. Then OR is the bisector of PQ. Therefore, what is the reason? The perpendicular from the center to a chord bisects the chord. Therefore, PR is equal to QR. If OR is bisector of the PQ means PR is equal to RQ. Therefore, PR is equal to QR. That is given two concentric circles C1 and C2 with the center O. PQ is a chord for the largest circle. Here PQ is the chord of the largest circle C2 which touches the smaller circle at R. This chord touches the smaller circle at R. Then to prove PQ is the tangent for the smaller circle C1. Then OR is perpendicular to PQ. That is, if PQ is a tangent for the smaller circle, then a tangent is perpendicular to the radius at the point of contact. Here the point of contact is R and the radius is OR. This is the PQ is the tangent. Therefore, we can say that PQ is perpendicular, OR is perpendicular to PQ. Then PQ is a chord of the circle C2 and OR is perpendicular to PQ. Then PQ is a chord of the circle C2 and OR is perpendicular to PQ. Therefore, OR is the bisector of PQ. Why? Here OR is the bisector of PQ. That is, the perpendicular from the center to a chord bisects the chord. That is the theorem. The perpendicular from the center to a chord bisects the chord. Then PR is equal to QR. Bisects means divide it into equal halves. Therefore, this OR divides this PQ into two equal halves. Therefore, PR is equal to QR. Therefore, we prove that in two concentric circles, the chord of the largest circle which touches the smaller circle is bisected at the point of contact. That is, OR is perpendicular to PQ, then a tangent is perpendicular to the radius through the point of contact. PQ is a chord of a circle C2 and OR is perpendicular to PQ. Then OR is the bisector of PQ because the perpendicular from the center to a chord bisects the chord. Remember it. Remember this two theorem. The perpendicular from the center to a chord bisects the chord and a tangent is perpendicular to the radius through the point of contact. Therefore, OR is the bisector of PQ. Bisector of PQ means the OR bisects this line, the chord PQ. That is, PR is equal to QR. Therefore, the two concentric circles, the chord of the largest circle which touches the smaller circle is bisected at the point of contact. Here the point of contact is R and the OR is the radius. Therefore, OR bisects PQ, bisects the chord. That is, PR is equal to QR. Therefore, the perpendicular from the center to a chord bisects the chord. You remember these two theorems. Okay, it's very important. We can do more questions in the next class. Assignments will be given through Google Classroom. Thank you and have you.